placement of a subpanel, particularly in a location like a cathedral ceiling, involves several considerations for a home inspector to ensure safety and code compliance. The electrical code requirements are paramount. The National Electrical Code, or NEC, sets the standard. Inspectors will verify that the subpanel installation adheres to the NEC regulations concerning clearance, accessibility, and protection against moisture and physical damage. This involves checking specific articles within the code that address panel installations and working space requirements. Secondly, safety is a primary concern. Inspectors assess the subpanel's mounting, ensuring it's secure and shielded from potential dangers such as falling objects, vibrations, or moisture intrusion. Accessibility is also crucial for both routine maintenance and emergency situations, such as needing to quickly shut off power. Inspectors look for adequate working space around the panel, as specified by the NEC, to allow for safe operation and maintenance. The subpanel's capacity to dissipate heat is thirdly a critical factor. Subpanels generate heat during normal operation, and inadequate ventilation can lead to overheating, potentially causing a fire hazard or premature component failure. Inspectors will ensure that the installation provides sufficient ventilation, whether through open space, venting, or other means. The design and construction of the shelf or enclosure are also evaluated to ensure that it does not impede heat dissipation. Fourthly, the conduit and wiring connected to the subpanel must be carefully examined. Inspectors check the size and type of conductors to confirm that they are appropriate for the intended load, as specified by the NEC. They also verify that the wiring is properly routed, supported, and protected against physical damage. Connections to the subpanel are inspected to ensure that they are tight and secure, reducing the risk of loose connections, which can cause arcing and overheating. Grounding and bonding are, fifthly, essential safety measures. Inspectors verify that the subpanel is properly grounded and bonded to the electrical system's grounding electrode system. This helps to protect against electrical shock and minimize the risk of equipment damage in the event of a fault. Grounding and bonding connections are visually inspected to ensure that they are intact and securely fastened. Sixthly, the overall workmanship and finish of the subpanel installation are evaluated. Inspectors look for any deviations from standard practices that could compromise the safety or functionality of the system. Issues such as exposed wiring, damaged components, or improper labeling are noted and reported. The finish of the installation, including the neatness and organization of wiring, is also considered as an indicator of the installer's attention to detail and adherence to best practices. When a subpanel is located in a cathedral ceiling, as in the question scenario, there are additional factors to consider. Firstly, accessibility becomes even more critical. Cathedral ceilings can be difficult to access, so inspectors must ensure that the subpanel is located in a way that allows for safe and convenient maintenance and emergency shut-off. This may involve the use of ladders, scaffolding, or other equipment to reach the panel. Secondly, the structural integrity of the shelf or enclosure supporting the subpanel is a key concern. Cathedral ceilings often have limited space and unique structural characteristics, so inspectors must verify that the shelf or enclosure is securely attached to the ceiling and capable of supporting the weight of the subpanel and its associated wiring. Thirdly, the limited space in a cathedral ceiling can also make it challenging to provide adequate clearance for wiring and connections. Inspectors must ensure that there is sufficient space around the subpanel to allow for safe and easy installation and maintenance of wiring. This may involve rerouting wiring, using smaller diameter conductors, or modifying the enclosure to create more space. The National Electrical Code addresses specific requirements for electrical installations, and home inspectors need to be well versed in these regulations to ensure safety and compliance. Firstly, NEC Section 110.3. B covers the examination, installation, and use of equipment. It requires that electrical equipment be installed and used in accordance with the instructions included in the listing or labeling. Inspectors check that the subpanel and its components are listed or labeled by a recognized testing laboratory such as Underwriters Laboratories or Intertech, and that they are installed according to the manufacturer's instructions. Secondly, NEC Section 110.12 addresses neat and workmanlike manner. It requires that electrical work be performed in a neat and workmanlike manner, which includes proper wiring methods, secure connections, and organized routing of conductors. Inspectors look for evidence of sloppy or careless workmanship, which can indicate potential safety hazards or code violations. Thirdly, NEC Section 225.32 pertains to accessibility of overcurrent devices. It requires that overcurrent devices, such as circuit breakers or fuses, be readily accessible to the occupant of the building or premises. Inspectors verify that the subpanel is located in a place where it can be easily reached in case of an emergency or the need for maintenance. Fourthly, NEC Section 312.5 addresses the space in enclosures. It specifies the minimum dimensions of enclosures for conductors and equipment, including subpanels. Inspectors check that the enclosure is large enough to accommodate the conductors and equipment installed within it without overcrowding or creating undue stress on the wiring. Fifthly, NEC Section 408.36 covers clearance around electrical equipment. It requires that sufficient access and working space be provided around electrical equipment, such as subpanels, to allow for safe operation and maintenance. Inspectors measure the clearances around the subpanel to ensure that they meet the minimum requirements specified in the code. Sixthly, NEC Section 408.38 pertains to the enclosure types. It specifies the types of enclosures that are permitted for use in different locations and environments. Inspectors check that the subpanel enclosure is appropriate for the environment in which it is installed, taking into account factors such as moisture, dust, and physical damage. Seventhly, NEC Section 250 provides detailed requirements for grounding and bonding. It covers the methods and materials used to ground electrical systems and equipment, including subpanels. Inspectors verify that the subpanel is properly grounded and bonded to the electrical system's grounding electrode system, as required by the code. Eighthly, NEC Section 310.15 details ampacity of conductors. This section, along with the associated tables, determine the allowable ampacity of conductors based on factors such as insulation type, temperature rating, and ambient temperature. Inspectors check that the conductors connected to the subpanel are properly sized for the intended load, taking into account the ampacity requirements specified in the code. The NEC includes tables such as 310.15, B16, and 310.16 that provide ampacity ratings for various conductor types and sizes. Understanding and applying these tables is essential for ensuring that the electrical system is safe and reliable. In addition to the NEC requirements, inspectors also consider other safety standards and best practices when evaluating subpanel installations. Firstly, proper labeling of circuits is crucial. Inspectors check that each circuit breaker or fuse in the subpanel is clearly labeled to indicate the equipment or area that it serves. This helps to prevent confusion and makes it easier to shut off power to specific circuits when needed. Secondly, surge protection is an important consideration, especially for sensitive electronic equipment. Inspectors may recommend the installation of surge protective devices, or SPDs, at the subpanel to protect against voltage surges caused by lightning or other electrical disturbances. Thirdly, arc fault circuit interrupters, or RFCs, are designed to detect and interrupt arc faults, which are a common cause of electrical fires. Inspectors may recommend the installation of RFCs in certain circuits, such as those serving bedrooms or living areas, to provide additional protection against fire hazards. Fourthly, ground fault circuit interrupters, or GFCIs, are designed to protect against electrical shock by detecting and interrupting ground faults. Inspectors check that GFCIs are installed in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Fifthly, regular maintenance is essential for ensuring the continued safety and reliability of subpanel installations. Inspectors may recommend that homeowners have their electrical systems inspected and maintained by a qualified electrician on a regular basis. This can help to identify and address potential problems before they become serious hazard. In summary, evaluating subpanel installations requires a thorough understanding of electrical codes, safety standards, and best practices. Home inspectors play a critical role in ensuring that these installations are safe, compliant, and properly maintained. By paying attention to factors such as clearance, accessibility, ventilation, wiring, grounding, and workmanship, inspectors can help to protect homeowners from electrical hazards and ensure the safe operation of their electrical systems. For a subpanel laying flat on a shelf in a cathedral ceiling, several specific considerations come into play. Firstly, the NEC mandates working space around electrical equipment for safety and maintenance. Section 110.26 typically requires at least 36 inches of clearance in front of the panel, 30 inches wide, and 6 feet 6 inches of headroom. If the subpanel laying flat on a shelf restricts this space, it violates the NEC. Secondly, subpanels generate heat, and proper ventilation is crucial. Enclosing the subpanel tightly in a confined space like a cathedral ceiling without adequate ventilation can lead to overheating, posing a fire risk. The NEC requires sufficient airflow around electrical equipment to prevent heat buildup. Thirdly, accessibility for maintenance and repairs is essential. If the subpanel is difficult to reach or requires significant effort to access, it hinders future maintenance and troubleshooting. The NEC emphasizes the need for readily accessible electrical equipment for safety and convenience. Fourthly, the structural integrity of the shelf is paramount. The shelf must be capable of supporting the weight of the subpanel and its associated wiring without sagging or collapsing. A poorly constructed or inadequately supported shelf poses a safety hazard. Fifthly, cable management is critical. The NEC requires proper support and protection for cables entering and exiting the subpanel. Cables should be neatly organized and secured to prevent strain on connections and reduce the risk of damage. Sixthly, consider the type of subpanel enclosure. The enclosure should be suitable for the environment. If the cathedral ceiling is prone to moisture or dust, an M-rated enclosure that provides protection against these elements may be necessary. The inspector should evaluate the surrounding environment and any potential hazards such as moisture. If moisture is present, the inspector should recommend an M enclosure with a suitable rating. If the installation fails to meet these requirements, the home inspector should recommend that a qualified electrician evaluate the installation and make necessary corrections to ensure compliance with the NEC and to mitigate any safety hazards. The home inspector should document these findings in a report and provide photographs of the location of the subpanel, the area where the shelf is, the physical appearance, the wiring, the clearances, any labeling, and potential obstructions. It is important to note that this information is for guidance only, and it is not a substitute for consulting the NEC or a qualified electrician. Electrical work can be dangerous, and it should only be performed by qualified individuals. In addition, local codes and regulations may vary, so it is important to check with the local building department to ensure compliance. The information provided is based on general knowledge and understanding of electrical codes and safety practices. It is intended for educational purposes and should not be considered as professional advice. Always consult with a qualified electrician or home inspector for specific recommendations and guidance regarding electrical installations. The NEC is a comprehensive document, and it is essential to stay up to date with the latest edition and any local amendments. Home inspectors and electricians should regularly attend training courses and workshops to enhance their knowledge and skills. Continuous learning and professional development are crucial for ensuring safety and compliance in the electrical industry. Furthermore, it is essential to emphasize the importance of safety when working with electricity. Always to energize circuits before working on them, and use appropriate personal protective equipment, or PPE, such as gloves and safety glasses. Never take shortcuts or compromise safety for the sake of convenience. Electricity is a powerful force, and it must be treated with respect. In conclusion, the placement of a subpanel in a cathedral ceiling requires careful consideration of electrical codes, safety standards, and best practices. Home inspectors play a vital role in ensuring that these installations are safe, compliant, and properly maintained. By following the guidelines and recommendations provided in this video, inspectors can help to protect homeowners from electrical hazards and ensure the safe operation of their electrical systems. Always remember to consult with qualified professionals and refer to the latest edition of the NEC for specific requirements and guidance. The electrical industry is constantly evolving, so it is important to stay informed and adapt to new technologies and practices. By embracing a culture of safety and continuous learning, we can work together to create a safer and more reliable electrical environment for everyone. Remember that the role of a home inspector is to provide a professional opinion based on a visual inspection. They are not code compliance officers, but they should be knowledgeable about basic code requirements and safety standards. When in doubt, always recommend that a qualified electrician be consulted. Electrical installations can be complex and potentially dangerous, so it is important to err on the side of caution. A thorough inspection and proper maintenance can help to prevent electrical fires, shocks, and other hazards. By working together, home inspectors, electricians, and homeowners can ensure the safety and reliability of electrical systems. Always prioritize safety and compliance, and never compromise on quality. The safety of lives and property depends on it.